In Unit 3, we talked about exponent rules, and there are a bunch of them, so we're going to go through them. Hopefully, this will help you kind of remember what they are. Remember, if you need more practice, there is some Delta Math assignments where you can do some practicing on these. So the first one was adding and subtracting. It's where you add like terms. The next one is multiplying. Then we did power to a power. Dividing. Negative exponents. And zero exponents. This is actually supposed to say expressions. Right, with adding and subtracting expressions, when you're adding and subtracting, you must combine like terms. Only the like terms. And remember, for it to have like terms, they need to be the same base and the same exponent. So make sure you distribute the negative when subtracting. So here on this first one, you can just ignore the parentheses because it's adding. So we're just going to add the like terms. 7x squared and 4x squared gives you 11x squared. 9x and negative 2x gives you 7x. And negative 6 and negative 1 gives you negative 7. For the next one, you want to make sure you see that this is subtraction. And so we distribute that out so it changes the sign of all of your second pieces. So negative 5x squared plus 4x minus 6. And you can just bring down the first expression and combine your like terms. So 3x squared minus 5x squared is negative 2x squared. 5x and 4x is 9x. And negative 8 and negative 6 is negative 14. When you multiply expressions, we multiply the whole numbers with the coefficients as numbers in the front. And then we add the exponents. So an example here, if you're looking at this first one, you're going to do 4 times 2 first and get 8. Then we're going to keep that base of x, but we're going to add our exponents 3 plus 2 and get 5. Pause it and try the next one, see how you do, and then hit play and listen to the explanation. Okay, negative 4 times 3 is going to be negative 12. And then we have our same base, x. Add 5 plus 2 to the 7th power. Here we're talking about power to a power. So when you raise a power to a power, we raise the whole number to that power and we multiply the exponents. Remember, we talked about this like distributing. So remember, everything inside has an exponent. So I'm going to go ahead and write a 1 on my 5. And then this 4 that's outside has to be distributed to each of them. So it becomes 5 to the 4th power and x to the 8th power. Because remember, with distributing, you always multiply. And then you can evaluate 5 to the 4th power if you would like. But you don't have to. It's 625x. No. Now I'm second guessing myself. Let me check. Yeah, it is 625 x to the 8th. All right, and then for the next one, you want to do the same thing. Make sure you write a 1 in on that 3. Go ahead and distribute that out. So it's going to be negative 3 to the 3rd and then x to the 18. If you do -3 to the third in your calculator, it's going to give you -27x to the 18. All right, when dividing expressions, you want to divide the whole number first. You want to make sure you divide them because a lot of times people try to do subtraction because that's what you're doing with your exponents. So make sure you divide your whole numbers and then we subtract our exponents. So here we want to look at 6 over 4 first. I'm going to actually write this out to the side. So 6 over 4, we want to simplify that because you can't, 6 isn't divisible by 4, but 2 does go into both of them. So 6 divided by 2 is going to be 3. 4 divided by 2 is going to be 2. So the first part of your fraction is 3/2. Then you got to look at the rest of what's going on. So we have x to the 4th over x squared. And so we want to subtract those. So that becomes x to the 4 minus 2, which just becomes x squared. And since it's positive, it goes on top of our fraction. Use that to try the next one. Pause the video and try it and see how you do. And I'll write out the work to the side. Okay, hopefully you paused the video and you see that you have 8 over 10, which they're both divisible by 2. So you're going to get 4 over 5. Then x to the 3 minus 8. And y to the 6 minus 2. So that's going to be x to the -5 and y to the 4th. And so then when we write that as our fraction, we're going to write our 4/5, 4 on top, 5 on bottom. But when we use this x to the -5, because it's negative, we move it to the bottom so it becomes positive. And y to the 4th is positive, so it goes on top to stay positive. Remember, you always want to have positive exponents. That's what we're going to talk about on the next slide. When you have a negative exponent, you need to move the negative exponent to the other part, meaning move it to the other side of the fraction. So like if it's on the top, it's going to go to the bottom. If it's on the bottom, it's going to go to the top. So when you move it, change the exponent to a positive because now it's happy. So we kind of talk about it as it being negative. It's sad. We don't like sad kindergartners. I think that's the way I used to teach. I don't know if I talked to y'all about it that way, but then when it becomes positive, it's happy because positive, happy. All right. So what we want to do here is we want to do the subtraction first. So x to the -5 minus -2. So remember that minus minus goes to plus plus. So -5 plus 2 is going to be x to the -3. But we can't have that. It's negative, so we got to make it a fraction and write it on the bottom. And you can't leave the top of the fraction empty, so we have to put a 1 on top. All right, looking at the next one, you have x squared minus to the -5th, because you're going to look at these two together. So we subtract, drew right through it. So we subtract those exponents. 2 minus -5, minus minus goes to plus plus. So this becomes x to the 7th, which means it's going to go on the top of the fraction. Then we look at the y's. So y to the -7 minus 4. -7 minus 4 is -11. So it's negative, which means it goes to the bottom and becomes positive. Hopefully this is the easiest one for you to remember. Anything to the 0 power is always 1. No matter what it is, no matter how much stuff you have here, because it's to the 0 power, it's going to be 1. Same thing here. Even though there's all that stuff inside, it's to the 0 power, so it's 1. All right, you should pause the video and try these on your own, see how you do on them, and make sure you're checking your work, and then hit play and check your answers when you are finished. All right, if you're looking here on the first one, we can just combine our like terms because it's addition. So it's going to be 11x squared. -5x and 2x gives me -3x. And then 2 minus 10 gives me -8. Looking at number 2, this is a negative here, so we need to distribute that out. So I'm going to rewrite it down here. 3x squared plus 6x minus 4 minus 6x squared plus 2x minus 9. So I've got 3x squared and -6x squared, which gives me -3x squared. Then I've got 6x and positive 2x, which gives me 8x. And then last, I've got -4 and -9, which gives me -13. All right, and on number 3, you want to multiply the big numbers first. So 6 times 5 is 30. And then you want to add the exponents. So it's going to be x to the 6. Looking at this, remember you want to always make sure you write in your ones and then distribute the 3 to each thing. So we get 4 to the third, x to the 6. Remember, distributing means multiplying. And you can do 4 to the third in your calculator and get 64, x to the 6. All right, if we're looking at the next one, we need to break this down into pieces. So we have 8 over 12. So we need to simplify that. Each of those is divisible by 4. So we get 2 over 3. Then we need to subtract our pieces with it. So x to the 5 minus 3 gives me x squared. It's positive, so it goes on top. And then y to the 2 minus 9 gives me y to the -7. It's negative, so it ends up on the bottom to become positive. And there's our answer for that one. Okay, looking at number 6, you need to do the same thing. So 6 over 8, divide both of those by 2. So you're going to get 3 over 4. And then you need to do x to the 5 minus -2. Minus minus goes to plus plus. So this becomes x to the 7th. So it's positive. So it goes on top. Then you need to do y. So y to the -5 minus 3 becomes y to the -8. It's negative. So it goes on bottom to become positive. All right, looking at number 7, anything to the 0 power is always 1, no matter what it is. The key part of rewriting a radical is making sure you know what goes on the inside, what goes on the outside. When converting a radical to fractional exponent, the power inside the radical becomes the numerator. The number in the index, which is the number on the outside, becomes the denominator. So we would rewrite this as x to the 3/5. The number on the outside, the index, becomes the denominator, and the number on the inside becomes the numerator. All right, so rewrite these next few. Pause it, see how you do, and then hit play. At least try 1 and 2 on your own. So this is going to be x to the 6/7. Number 2, remember if there's nothing written out here, it's called a square root, so it does have a 2 out there, so this will be x to the 3/2. This one, number 3, because it's written in parentheses, you need to keep it in parentheses, so 2x to the 11 over 6. And the next one, since it is not in parentheses, each thing has its own exponent, so this is going to be 2 to the 1/3 and x to the 4/3. So now we're going to go from fractional exponent into a radical. So the numerator becomes the power inside the radical. The denominator becomes the number in the index, which means the number on the outside. Ooh. Index, not an S and X. All right. So then x to the 2/5, you write a radical. The 5, because it was on the bottom, goes on the outside. And the 2, because it was on the top, goes inside with the x. So try at least 1 and 2 on your own, and then 3 and 4 are a little bit more complex. So first write your radical. 5 on the outside, x to the 4th on the inside, 3 to the 1/2. So, oh, that's supposed to say 3x to the 1/2. Sorry, I think something must have accidentally gotten deleted there. So only the x has the 1/2, so it's 3 root x to the 1st. Number 3, since the 6x is to the whole in parentheses, so that means the whole thing gets an index of 11. So then we want to keep it on the parentheses on the inside. And then the last one, they both have a denominator of 4, so that means you can have a radical with a 4 on the outside. So inside, this is going to be 4 to the 1st power and x to the 5th power. You don't have to write that one, but you can. All right, when solving rational equations with 2 terms, you must cross multiply. So remember, you can only cross multiply when you have an equal sign between 2 fractions. So right here, you have an equal sign between those 2 fractions. So what you're going to do is you're going to multiply 5 times 2x plus 1. And that's what you see written here. and 20 times x, which gives you 20x. Then you want to distribute and solve, kind of like we did in class. So you get 10x minus, or 10x plus 5 equals 20x. Then you want to minus the 10x on both sides. So then you get 5 equals 10x, divide by 10, you get a half. All right, maybe pause it and try this one if you're still a little confused. I'm definitely going to work it out. So we're going to cross multiply. Cross multiply. So 5 times 4x minus 2 equals 2 times 4x plus 7. Then we want to distribute each of them. So 20x minus 10 equals 8x plus 14. I'm going to minus the 8x on both sides because it's smaller. So I get 12x minus 10 equals 14. Then I need to finish solving this. So I'm going to add 10 on both sides. So 12x equals 24. Last step, we divide both sides by 12. So x equals 2. All right, with exponential functions, they can either represent growth or decay. Growth means it's growing, it's getting bigger, like you want your bank account to do. Decay means it's getting smaller. Like, I don't know, like all I can think of is like carbon and fossils, but I know that's not going to make a lot of sense to you. All right, so it's a times b to the x. That should be a multiplication symbol right there. So a is the initial value. B is the growth or decay rate. If the problem uses 1 plus a rate for B, it's growing. If the problem, if the problem is growth, use 1 plus the rate. I didn't read the first part. Silly me. If the problem is decay, 1 minus the rate. Because decay would mean taking away, as growth is it getting bigger. X is the time. All right, so we want to write an equation for this. So write an equation for the situation. The amount of movies made in 2015 was 1,255. The number is expected to increase by 2.1% every year. So we want to write that equation. So y equals the amount we started with, so 1,255. And it said it's growing, it's increasing, so 1 plus 0.021 to the x. Now, the reason we have to make that 0.021 is you can't plug percents into an equation. You have to make it a decimal first. And remember, to make it a decimal, we move it 2 places to the left. So it'll be 0.021. And that would be your equation. Pause it and try these next two and see how you do, and then come back and check. All right, if you're looking at this first one, it's going to be y equals 5,056 times, and it's increasing, so 1 plus 0.056 to the power of x. Number 2, the number of people who live in North Dakota, which is currently 739,482 people, decreases by 1.3%. So we're going to do the rate of 1 minus 0.013 to the power of x. You can simplify these if you want. You don't really have to, because it is going to be written as plus or minus like that to ask you if it's growth or decay and such on your test. There are a lot of real life situations where you'll see growth and decay. It's actually one of the more useful things that we learn. You can use these equations to predict outcomes in the future. In order to do this, use your calculator to put it into the equation and use the table to find the values. So it gives us the model, and then it asks, find the initial population. Remember, the initial population is always this number in the front. So 604,000, so 604,000. Is this growth or decay? Well, look right here. It's a plus sign, so we know that it's growth. Predict the population in 1995. Now, this is the population after 1990, so we're going to plug in x equals 5 into this equation. So make sure you have your calculator and try that. So when I plug that into my calculator with x is 5, I get 75269.3, and it says 0.89, but This is, you can't have partial people. So what we're really going to say is this is 752,694 because it is people. So 752,694 people. In what year will the population reach 1 million? So the easiest way to do this is to kind of look at it in the table. So if you will go into y equals and type it in, I'm going to show you how it looks on my calculator. All right, I pulled these two things off of my calculator. This right here is how I typed it in. So that's what it looks like, to the power of x. And then I hit second graph, which takes me to the table. And if you notice, this answer is the one we had right here. So you know we're on the right track. So then you wanted to say a million. So you needed to have one more digit. Well, you notice after it has 9 in the 100,000s place, it goes to this funky number. It says 1.02e to the 6th. So that means it's 10 to the 10 to the 6th power, which means it is officially in the millions. So if you're looking at that, then you can actually put your cursor over top of this number and it'll give you the actual number. But we don't need to see that. We just need to know what year it'll reach a million. So it'll reach a million 12 years after 1990. So 1990 plus 12 gives me 2002 as my answer. Hopefully this was helpful. If you have any questions, please don't hesitate to ask and work on some of this in Delta Math.